Sorry, which one? 3, 3?
3.3, like 57.
Oh,
It would have been like 54.
54. Oh, okay. Yeah, it's sort of related to 57 and all that. Let's look at 58, just to be different. Yeah. Yeah, so if you solve each of these for y, why would you do that? What does that do for you?
See it better?
See what better? If you solve for y, what form are you putting it into?
Y equals the y-intercept. That is what it's called.
That's fine. Y must just be a slope-intercept form. And this is actually kind of, either you don't think about it enough and it's not that freaky, or you think about it, it's kind of freaky. Just by solving for y, everything falls into place. And a lot of people forget why it makes sense that b is the y-intercept, m is the slope. It's not, we just said, oh yeah, let's just say it's that. It's because it really is. And we talked about, of course, b is the easy one. How do you find the y-intercept? You set x to 0 and you get y equals b. That's easy. That's a quick explanation. That's why the b is the y-intercept, because it is. When you make x 0, you get b. And I explained last time about how the m is like a multiplier, an amplifier I called it. If x changes by 2, y will change by m times that much. And that's exactly the idea of slope. As x changes, how much does y change at the same time? That's the slope. So m is in the right place to be the slope. So if you solve both of these and put them in this form, what is it you're going to look for with the slopes? Parallel lines have exactly the same slope. Perpendicular lines have totally opposite. If one is 1/3, the other one's going to be -3. You switch it both ways. Make it a different sign and you flip it. Okay, cool. And we talked about, I gave you a specific example last time. It's like a 1/3, and -1/3 wouldn't be enough. -3 makes it meet at a right angle. -1/3 would make it meet like that. It's not a perpendicular. That's perpendicular. All right. So if you solve both of those for y, here you'll get, and here you get, what's this guy's slope? What's the first guy's slope? 4/3. What's the second guy's slope? 4/3. So are they parallel, perpendicular, or neither? They're definitely parallel. Cool. Now, one extreme would be they have the same slope and they have the same y-intercept, so they would be
the same line.
The same line. You wouldn't call that parallel, would you? Parallel, they're not supposed to meet anywhere. If they're the same line, they meet everywhere. That's kind of like the opposite extreme from parallel. They meet nowhere, they meet one place, they meet everywhere. Yeah.
How'd you get the 4/3?
Oh, I skipped a few steps. Add the 4x, divide by 3. Oops, so this should be 4/3. Doesn't really matter. The slope is the same on both. Cool.
What made you think it was 1?
My brain, I saw the 4s and made it 1.
Oh.
Yeah, I was doing it too quick.
So it's not 1, no, it's
So you just made the y the 0 and then did it from there?
No, so all I did was...
Sorry.
That's all right. So take this here. How do you solve for y? You get this out of the way first.
0 and
Yeah, I'm not looking for an intercept. I'm just trying to get y by itself. And then the last step is just divide by 3. So every now and again I will do that. I'm focusing on one concept. I'm going to assume that we're all able to solve. So definitely ask me if I made a mistake. So that's an excellent place to ask me. Where the hell did you get that 1 from? Oh shit, I divided wrong, but yeah.
So the y-intercept is 4/3 as well.
Beautiful. And that's just a coincidence, right? Doesn't have to be, doesn't mean anything. Cool.
So that's all for the next one.
And then the next one the same way. So that's the first guy. The second guy, I would add 8x over, divide by 6. That reduces to 4/3.
So they're.
So again, when they ask me, are these parallel, perpendicular, or neither? Parallel and perpendicular both have something to do with the slope. So I say, how do I find the slope out? What's the quickest way to find the slope of a line? Solve for y. Put it in this form. Because then I can just see the slope. Just stare me in the face. It doesn't happen very often in math, but here it does. There it is, just staring you in the face. And you go, okay, they are the same, sweet. And they must be parallel.
If they're not opposite or parallel.
Then they're neither. And of course, I mean, think about it. The thing that would happen the most is neither. Because there's a lot more ways to have it just meet somewhere and don't have to come at a 90-degree angle. It's a little freaky to have parallel. That's not going to happen very often. It's a little freaky to have perfectly perpendicular, 90-degree. What's going to happen most? Going to meet in some weird angle. So neither is actually the most going to happen. Now, in the homework, they're going to make it most of the time come out to be one or the other to get you used to the idea.
Yeah.
What about on tests?
Same thing for me.
Okay.
But if I just make up, if you just, whoa, now, if I magically make things appear. If I just make up two equations of a line, just add in, just, 3x minus 5y equals 11, 4x plus 6y equals 20. Just making something up. They're probably not going to be either one. And to tell you honestly, I just threw up whatever numbers happen to come to me. So if I solve each of these for y, I most likely will have neither situation. And sure enough, if I solve the first one for y, I get that. If I solve the second one for y, what do you get, Joe? I don't know. Negative.
Say that way.
Something like that. So are those parallel or perpendicular?
Neither.
They're definitely not parallel. And they're definitely not perpendicular. And they're not opposite reciprocals of each other, right? They're not negative reciprocals. So this is an example of neither
So to write it, you just want
parallel or perpendicular. Yeah. Yes, sir.
So in the process of doing this, after you solve y, you solve x, and then you just input it into...
Just solve for y. And then the number in front of the x is the what?
Be slope.
Slope. Beautiful. And that's all you need. If you compare slopes, you can tell if they're parallel, or they're perpendicular, or they're neither.
Well, I understand that part, but where are we getting the slope for x? And taking the 58, number 1, when you have 4x plus, the y equals to 4 over 3x plus 4/3. Where am I getting 4/3? Again, sorry,
Are you cool with the steps I took here?
yeah.
Okay. And so I'm just solving for y. So these two are both the same. Are you cool with that? They don't look the same, but they are the same equation. If I plug stuff into here, it's going to be the same as here because they're both the same. They just look different. So I just solve for y. When I solve for y, it's mx plus b format, so I know that's the slope. How do I know it's the slope? It's in the right place. And some students just accept that. Some students forget that and they think that's too easy. It's got to be something more complicated, right? It can't be that easy. Of course it is. It is that easy. I would love it if you understood why that's true. Why the number that's here is a slope and the number that's here is the y-intercept. Every time x changes by 1, y is going to change by 4/3. Or even better, if I do this, well, that's kind of gross with the 4/3, but too bad for us. Let me look at the other example. There, let's use that one. If x is 3, what's y going to be? If x is 3,
4/3 more.
we'll plug a 3 in. What do you get?
3 over 1, right?
If x is 3, so you plug a 3 in. What do you get when you do this? Yeah, the 3's
Cancel off.
cancel. So y is 4. If x is 6, what do you get for y? Yeah, 3 goes into 6 twice. 2 times 4 is 8. How much did x change by?
That's double?
Not double, but how much did it actually change by? What's the difference? 3. How much did y change by? What's the slope supposed to be? 4/3. Isn't it rise over run? The y's changed by 4. The x's ran by 3. You can see it happening, right? That's why that number is the slope, because I'm going to multiply x. If x changes by 3, y will change by 4/3 times that. It'll change by 4. That's exactly what the slope is supposed to tell me. How much does the y change, rise or fall? And how much does the x change, run, forward or back, right? So that's why that number there is the slope. If I solve for y, that's the slope. And whatever's here is the y-intercept. What would be the y-intercept for this line? What would be the y-intercept for this guy? 0. 0, 0, the origin. Right? What's here? Nothing. Well, there really is an understood plus 0 there. So the y-intercept is 0, 0. Okay. Maybe. So, 2 things involved in this problem. The understanding of what it means to be parallel or perpendicular. And then secondly, how to get what you need to determine that. Right? So if I know that parallel or perpendicular are related to slope, how do I get the slope the quickest? Solve for y. Then I can compare them, yeah. Cool. Which one? Sure.
How do we solve for y?
So that was this guy, where I added at 8x, and then divide by 6. Yeah. So I just took that guy over there just to really look at him a little closer.
3.4?
Yep.
Number 57, it had fractions on it. So, yeah.
Guys, which one? Sorry?
57 on 3.4.
Cool. All right. That's a good little review of the last, one of the last things we did last time. So remember, last time we did this, we expanded our knowledge of equations of lines. And trust me, I understand what you're thinking right now. Good God, how much do we have to look at lines? Oh my God. But you can't begin to understand how important it is to see what graphing is, what it can do for us. These equations help us, because we see these equations all the time in real life. We did an example last time with the bus tickets. Would it be better to buy a packet, or would it be better to just pay for every day as they go along? If I don't know the idea of this, I can't figure that out exactly. And nowadays, it's freaking important and be able to figure that out exactly. I want to save money. Always, but especially right now. So we have this equation here, but then we have this equation here. And this one is more general. This one requires me to use the y-intercept. Whereas this one says use x1, y, whatever point you want to, plug it in there. As long as it's a point that the line goes through. Okay. So for this problem, number, which one?
57.
57.
I got stuck in that fraction. That was what I didn't know what to do.
So whenever you see the instructions say find the equation of the line that, and it's followed by something, anything, what 2 things do you immediately know you need? A point and the slope. I like it. This problem is crazy nice because they gave me both directly, right? There's no work to do for either one. So they told me the point was -4, 1. Check. And they told me the slope is 3/4. Check. So we did a problem last time where it was 2 points. So of course, if I give you 2 points, you can find the slope. And if you have 2 points, you definitely have 1. You can pick whichever one you want. So last time we did it both ways. Here they gave me direct. I don't have any work to do. I just have to plug it in to the right formula, right? Which formula can I use directly?
2.
Now, some of you guys I know, you know how to use 1 to solve for b. I think last time I said I decided not even to show you that. So if you know that, great. If you don't, I really want you to get used to this anyway. Just plug it in here. Here's your one point that you know. Is it the y-intercept? The biggest mistake I see is somebody just puts a 1 there. Where'd that 1 come from?
The wrong point.
The y piece of this, but that's not the y-intercept. How do I know that's not the y-intercept?
Because y
X is not
0.
0. There you go. Cool. So be careful. B is not whatever number I see there. Right? B has got to be specifically 0 comma something. That's the y-intercept.
If you are given the point with 0 and 1.
Sweet. Then you use this one. This one would work. This is more general than this. This one works always. This one works more specifically when you know the y-intercept. There are ways to make this one work for this situation. I'm not going to get into it now. So, here's my equation I know I want to use, because it has room for a point to go in there. Y minus what?
1.
Good, because that's the y piece. And if you want to, you can call this x1, y1, because that's the one point you know. When you have a subscript, that means it's a specific thing, something you're given. So that's why I call it x1, y1, for the one point I know. So y minus 1, what's m?
3.
3/4, they told me that directly. X minus,
4. So is it plus 4 really?
good, x minus negative 4, I like it. We still have trouble with that.
Could you just do add 4 though? Or
I like it.
Okay.
Yeah.
Just don't do x minus 4 and say there's already a minus. Why do I have to write another minus? Because you have to. They're both there. So like you said, it should really become plus 4.
Okay.
Cool.
Makes it look better. Not as hard.
Then the less confusing.
Yeah.
No, either you think about it ahead of time, or you plug them in and you go, oh, there's 2 negatives. Let me make it a plus. Right? Different people like different ways. What's my next step? And this is nice.
So
Distributed property.
would you do that? Or would you add the? No, you don't add the 1.
Can you guys see what I noticed that makes this a nicer problem than it normally would be? Yeah. When I bring that 3/4 through, like you said, distributive property, there's a 4 in there that's going to go really well with that 4 on the bottom.
So it cancels out.
Eventually. So 3/4 times x is
3/4 x.
3/4 x. 3/4 times 4 is 3.
And that's because you put the 1 under the 4 and then they cross out.
The 4 cancels with the 4. I like it. Cool. Can you guys see that? Yes. Okay. Seeing no no's and moving forward. And then the last step, because the book says to put it in the slope-intercept form, and I'm going to want it in slope-intercept form. It's kind of like the nicest, most compact form.
So when you get to here, you're just now you're trying to make it into the y equals mx
Exactly.
plus 2
Solve for
form.
y. So how do I solve for y?
Add 1.
Add 1.
And did you just, is that the end of the, so you didn't need us to graph that?
It doesn't say graph it, does it?
I don't remember.
No.
So then that's it. That's the answer.
That's it. So when you're doing your homework, it's not terrible if you graph too much. It's terrible if you don't graph enough. So pay really close attention to when they ask you to graph it, or when they ask you not. You don't have to graph it, right? Definitely graph those you must graph. Yes. Now come over there.
I had one on 3.2, number 55, page 196.
55. Oh,
Because I
okay.
wasn't here that day, so it said to, in what coordinate plane? I didn't know. I don't know what to do.
So, guys, what is a plane? And I'm not going to make a big deal out of this because it's a small thing, but what's a plane? Not with wings.
Flat surface.
Yeah, like a flat surface, two-dimensional thing, right? So this is a plane here. So when they say coordinate plane, they just mean I've set up my coordinates now.
Okay.
So this is a coordinate plane because it goes in 2 dimensions, right?
Okay.
So they say, what would it look like? They don't say graph it, I don't think. They say describe what it would look like
Yeah.
if you graphed it. So you can say it would have a y-intercept of this with a slope of this. It would be increasing, however you want to describe what it would look like. All right, I don't think you had to do that one specifically, but
No? Maybe I
can't remember.
got it wrong.
No.
no. But that's okay. You can still do that one. Solve for y, and then you can see everything you need, right? Put it in the mx plus b form, yeah. Okay. Any other questions from, I think, did you have a?
75, section 4, 3.4.
Oh, cool. All right, perfect. So here's a really good example about why I desperately want you to realize when you have a find the equation of a line that problem, you say slope, point. Focus your attention on how do I get the slope, get it, and then say how do I get the point, get it. Very often they're just going to give you a point. I think last time I did a problem where I said it has the same x-intercept as something else, so we actually had to figure out the point. Do you remember that? It's been a while. So this problem says, which problem was it again? 75. Section 3.4. Find the equation of a line that goes through 2/3, 2/3, and is parallel to, where'd it go? 4x minus y equals -2. So what two things do you need again?
Slope and line.
The slope and a point. Cool. Of course, which one do we have already?
We have a point.
We have a point. We don't have the slope yet. So they gave you a point directly, 2/3. So the other piece of this must tell me how to get my slope. So I'll be very careful. I have two things going on. I have a line that they give me that my line does something with. Then I have my line. So don't just solve this for y and say, there you go, Jeff. There's the equation of a line. Yeah, but it ain't the line you're supposed to get. Plus you. If my line is parallel to this, how do we relate?
The slope's going to be the same.
Slope's going to be the same. We're not going to touch, so our slopes have to be the same. So how do I get my slope?
Did you plug in the point?
Do you fit my?
Yes, solve for y, right? The quickest way to get the slope of any line is to solve for y. The slope just gets right in the right place. It just comes up. And as a student, it's really weird. That's so damn easy. It shouldn't be that slope is hard, man. It shouldn't be that easy. But that's it. We've done a lot of work to explain why mx plus b works. Now just do it. You need the slope for whatever the hell reason, solve for y. The slope just comes right out. So how do I solve this for y?
Subtract 4x equals
All right. Yes, ma'am.
and then divide by -1.
Good.
It's 4x.
So what's that guy's slope?
4/1.
So what's my slope? Don't go too big. Yeah. 4/1. Same thing. It's parallel, right? Parallel. So my slope has got to be the same. So I know my slope is 4. Check. No. See, those are the two things I need in order to find the equation. So now that I have those two things, we're at a level that I call the SDT level. It's the same damn thing. However you found these two things, either they gave it to you or we did some work to find it, I just plug it in. It's the same damn thing. Once you get these two things, you just plug them in.
Into the other equation.
I like it. Why can't I necessarily use the B equation? Mx plus b, because I don't have the y-intercept. Again, if you know how to solve for b and you've been shown that before, great, do it. But I kind of want to emphasize this a little bit, so I'm going to stick with this way. So what would I put here? Y minus
3.
Beautiful, that's the y piece. y minus the y piece is m is 4 times x minus the x piece, 2. And then just clean this up a little bit. Distribute, get your y by itself. So 4x minus 8. Add 3. Coolness.
So 4x minus 5.
I love it. How do you check yourself?
Plug in.
Check yourself. Yeah, you just plug in 2, 3, and make sure that it works.
Oh, okay.
Twice 4 is 8, minus 5 is 3. 2, 3 works. Thank God.
So if they wanted it, if it said through that point and is perpendicular,
Then right here,
slope would be
m would have been negative
4.
1 over 4.
Oh.
Perpendicular means
Totally.
totally
So
opposite.
you have
You
to
change
flip
the
it too.
sign and you change
Okay.
orientation, right? You flip it.
Okay.
So if it would have said perpendicular, and some of them do,
Yeah.
slope here would have been negative 1 over 4, and I would have just put a negative 1 over 4 here.
Okay.
Oh, okay.
You get that?
Yeah.
Why was it a 4? Because it was parallel. It's exactly the same. If they said perpendicular, my slope here would have been negative 1/4. And I would have put that here, and it would have been a little uglier, but, right?
Okay.
So you better be certain that I will give you a problem exactly like this on the test. Right? Parallel, perpendicular, whatever I want.
Yeah, but you cannot say the other one is not only one from this. This is, you showed one is neither, not perpendicular or.
Oh,
You cannot
I'd have to
say-
give you something.
Yeah.
Yeah, I can't. We don't know how to handle if I said it was like at a 50-degree angle. Screw that. We only know how to handle if it's parallel or perpendicular. Yeah. So don't worry, I won't give you anything beyond what you'll see in the homework. Okay. Any other questions before we move on? All right, I feel a little better. If I get no questions at all, I try to be an optimistic fool, but yes.
If the point is it was the last one, it's 0, 3. So I can apply any
Then you could use, if it was 0, 3,
Yeah.
then you could use either method you want.
Either one.
Because 0, 3 means B would be 3. Cool. Okay. So let's review that last thing we did, which was the plotting a line and shading one side or the other.
Yeah.
And then we're going to get into chapter 4. Yeah. Let's see. So, as so often happens in here, the very last thing we learned, the graphing of lines. If you don't quite get that, the next section is going to be very, very difficult. Because this section, this last section that we do in chapter 3, the very last section in 3, by the way, 3-6, we're going to do at the very end of the semester. Because it's one of the first things you do in the next class. That's why I push it all the way to the end. But if you don't understand how to graph a line, the very first step in section 3.5 is graph the line. So that obviously will suck, because they add stuff on top of that. So in section 3.5, we'll see stuff like graph the solution for this year. And the whole idea to this section is that when I have an inequality, there are more answers than normal. Because if I said you have to be 35 years old to be the president, not so many people are exactly 35 that want to be president, right? But what is it really? You have to be at least 35. Well, now there's a lot more people that match that. Did you know it was 35? Yeah. So if this was equal to 2, I just get a line. But the minute I put that inequality in there, there should somehow be a lot more answers. So how do I solve to see the line that I'm working with?
Same thing
Exactly. If I have a line and two variables, it can never be different. If I solve for y, I can see my line, the slope and the y-intercept. So what do I do?
Plus 3.
Good. Add 3x. So what's my line's slope and y-intercept?
Y is less than 3x plus 2, right? Or what's the slope? 3 over 1.
Good. 3 over 1. And the y-intercept? 0, 2. Cool. So now you graph that line. Now I don't think I had an example last time that was like this. I can't remember now because I don't think we did too much of this yet. But when I have strictly less than, remember way back in the day we did closed circle?
Mm-hmm.
That was for less than or equal to, greater equal to. What is it if it's strictly less than? It would be
Open.
so somehow this can't be a solid line. It's like a filled in circle.
Just dotted.
This has to be a dashed dotted line, right?
The closed one? Oh, sorry.
So to show that it can't, can y equal this line?
No.
No, y's have to be less than this line. So you can't include the points on the line, can you? Because they have to be less than that. So that somehow I've got to have something. I don't want to put a bunch of little open circles. You actually could, but we use a bunch of dashes. Dotted line, yeah. Okay. Okay, that's exciting. So what's my y-intercept is 0, 2. You always plot a point that you know first, because then the slope will always get you back to the line if you start on the line. So 0, 2 is a point that I know.
The y integer that you put is the same thing when you put a point, right? It's the same thing? You know how you put slope and then point?
That's if I want to find the equation line. If I have the equation line, I know these two things. I know them. But see, that's why I need these two things to get an equation of a line. Doesn't that make sense? Because if I have an equation of a line, I know these two things. So to get an equation of a line, I need those two things. But I know them. I know them just by looking here. So 0, 2. And then the slope tells me to go
Up 3 over 1.
good, up 3 over 1. 1, 2, 3 over 1. If I wanted to, I could also go 1, 2, 3 down,
And then -1.
back 1. Because 3 over 1 is the same thing as negative 3 over negative 1. Mathematically before, that's never meant anything. That's like, well, some idiot didn't reduce that. But now, the slope totally changes direction now, but it still gets me back to the same line. You can see that. Again, I got to do a dotted line. I'm not quite as lucky as last time. Oh, little curve in there. So again, that dotted line is because it's like an open circle. It's telling people that line is not an answer. Now who remembers the second step?
You gotta shade
Shade
it.
the one that has more.
Shade the one that has more.
Is it?
More answers? Yes.
Shade the side that has all the answers? How do I figure out which side has the answers?
Plug in.
Plug in any damn point you want to in reality, right? I can plug in this point, I can plug in that point, I can plug in this point. Now, of course, to be smart about it, I'm going to plug in the point that makes me have to do the least work. I'm going to plug in the origin when I can. Bless you. You guys with me? If I plug in this point and it works here, that means that side is all the answers. The other side is not answers. If I plug in that point and it doesn't work, that means this is all not answers. I shade this way.
And what do you mean when it doesn't work? Like,
If it doesn't make this true.
oh, okay.
Cool?
So when you pick a point, it's not one that's on the line, it's somewhere
It
in the
can't be
graph?
on the line.
Okay.
Beautiful. So I can't pick this point because it's not going to tell me which side to go on. It's on the freaking fence. I need somebody on one side or the other. I can't pick a point that's on my line. So if you like the point 0, 0, which I do,
Just always
it
go.
sucks when the line goes through 0, 0. Well, then I use 1, 0.
Oh, okay.
The next easiest point, right?
Just stick to the first.
But right now I can use test point 0, 0. I really want you guys to understand how simple this really is. It sounds like a lot of work because I use a lot of words to talk about it. But it isn't. It's got to be all the answers on one side, all the not answers on the other. So if one point works, all of them work on that side.
So you plug in the 0 to, or I'm sorry, you plug in whatever test point.
Yep,
into the
0, 0. Into the equation, yeah.
So why would it become 0?
So 0 less than 0 plus 2 is 0 less than 2.
No. What?
Let's try this again. So 0
Yeah.
less than 3 times 0 plus 2 is 0 less than 2.
Yeah.
Stay with me now.
Yeah.
Yes, it is. Sorry, I was just keeping somebody away. 0 is less than 2. So what does that mean about the point 0, 0? Did it work in here?
Yeah. So you're gonna shade the.
It worked because it was true.
Is it mostly gonna work? Unless it's, if it's on the other side of the 0, 0, then it's not gonna work. Is that what you mean?
Exactly.
Okay.
If this would have been a greater than, it wouldn't have worked. I'd have to shade the other way.
Oh, okay.
Right? But this worked. This is true. So I shade in the direction of the point that I plugged in. I shade in this direction. So what about that point? Will that point work?
Yeah.
What about that point? Will that point work?
No.
No. Do you see that? And really, where this is going, just to kind of show you, because this is like, I have no idea what you guys think about this. You think, okay, great, Jeff, you're adding shading into this. Bring out my colored pencils if you want. That'd be great. What this is eventually getting to is you can have an equation that represents, the number of people that can fit on an elevator and the weight of the people, and you end up with a bunch of equations, but this is like your safe area. This is your restrictions, and this is your safe area. If you're out of there, the elevator might plummet. Bad.
Can you show
Right.
us one that won't, that is not equal? Like where we would shade the other side?
Sure.
I mean,
Yep. Let's do another one here. Oh. Yeah.
And, for the shading part, I understood everything except for what side to choose, to shade.
So the idea, if I was going to graph an inequality, and let's say you don't even really know what this is going to look like. You know it's going to look like either, let's go back to circles for a second. It's going to look like this or this. That's your two big possibilities, right? And of course, we know it's going to look like that, or that's fine. What tells me if it's going to go that way or that way is we have the shortcut of the direction this thing is pointing, right? Because it's only two directions. It's not a big deal. When I have this, it's kind of a little more involved. There's not just a point in the middle, there's a whole line. But what I could do here is I could actually plug in points. If I plug in a 5, does it work? So it can't be this. It must be this. So really here, there's a line now, but how many halves how many sides have I created? 2. This side and that side. So either every single point works or it don't. And that's why I only have to test one. If the point works, I shade that way. If it doesn't work, I shade the other way. Because there's only 2 options in this inequality. Either it's down here or it's up there. Let me see if you guys understand this. Test point is a great way to do this. The way I do it, less than, right? Less than?
Mm-hmm.
So here's a y on the line. Where's the y less than that? Down here.
Mm-hmm.
So I just shade down. Down and up get a little freaky when the line gets really steep. Then it looks more like left and right. That's why a lot of students don't like that. But that's how I don't do the test point personally. If I had to do this problem, I would just say less than, I shade down. But that doesn't look like so much down. It looks like,
but is that generally the rule? Like if it's
yep, that's
down?
exactly the rule.
Okay.
So it's perfectly fine to do that. Just be really careful. You understand when it gets really steep, down is not so easy to define, right? But I just go like this. Here's a y right there. What's y right there? -1. Where's the y less? Because that's what it says. Down here. The y is less down there, so I'm going to shade down. That's a quicker way to do it than the test point. If you don't quite get that, do the test point. If you don't quite get the test point, come and see me. So here, you guys try this one. Sure.
When it's negative like that, which one's negative? Are they both negative?
If they were both negative, the negatives would cancel, it wouldn't be negative.
Oh.
So either negative's on the top, or it's on the bottom. It's up to you.
Or.
Exactly.
Oh, okay.
So it's a good way to do it if you haven't made your graph big enough, put the negative on the other side so you're going up and back instead of down and over.
Okay. Okay.
I'll do it both ways up here.
Cool, thanks.
Make sure everybody's on the right first step. What do you do very first thing?
Solve for y?
Solve for y so you can see your line. Otherwise, not as easy to graph it. A lot of people get the y and x intercepts here. They're not always very nice.
But that's normal. Sometimes it'll just be odd intercepts where it's.
Yeah, it'll be kind of weird.
That's the, sometimes I was on the clock.
Good. Well, where's 0, 0? Where is it? It's over there. So that didn't work. So should you shade? Good. Shade away from it. Cool. So that's what you get when you solve it. What's your y-intercept?
-2. 5, 0, -2.
Good. So y-intercept 0, -2. So again, anytime, I don't care what the problem is, anytime you have a line that you need to graph, I would solve for y so I can see my slope and my y-intercept. The first step on these problems is draw the line that separates answers from not answers. So that's why I'm solving for y, so that I can see the line. So y-intercept is 0, -2, what's the slope?
-5 over 2.
Or?
Negative,
5 over -2.
Okay.
Mathematically, they're the same. Graphically, they're a little bit different. Sort of like getting there and getting back home. I have to be able to go both ways. Wow. Okay. Let's decide. Okay. So, what do I have to do first?
The y-intercept.
Y-intercept. Y-intercept is 0, -2.
And then go up.
So I could go down 5, 1, 2, 3, 4, 5, and over 2, right? That's down 5 over 2. But if my paper ends here, which happens, if you have graph paper like, shit, I didn't leave enough room. Just realize, move the negative to the other side. What's that now tell me to do? 5 over negative 2.
Up 5.
So it's up 5, 1, 2, 3, 4, 5.
To the left.
Back 2, 1, 2. And that I have enough room for, right? Don't quite understand that? Okay. But it will help you in some situations.
So you went up 5 over 2 to the negative side.
Exactly. Because it tells me up 5, the positive, back 2 because it's negative. And see how now that keeps it on the same line? Cool.
And then so, isn't it a dotted line?
Dotted line, thank you. Just about to look at it.
I made that mistake first.
So this is what you're talking about, the different sides and shape. It's kind of, you don't know. Because, never mind.
Yeah, it's a little, if it's really steep, down and up are hard to tell.